I wanted to jump right in today with our new material because we're hitting what I think is one of the most useful topics in math. Along with our ratio and proportion, this builds off of that, and it is percents. To understand how percents work, you have to understand the word percent. Percent is actually two words. Per, if you think of like miles per hour or dollars per hour, miles per gallon, things like that, it means out, or for each or out of. And then cent, if you think of years in a century or cents in a dollar, that's 100. So percent literally means out of 100. So if I have 34%, that literally means 34 out of 100. In fact, the symbol for percent, this little symbol here, originally looked like that. It's actually a blank fraction or a ratio. That's what percents are. Percents are a standard ratio where we're comparing everything to 100. Now, because of this, it's actually just this simple to change a percent into a fraction. 34% is 34 out of 100. Now, of course, we wouldn't leave it like that. What would we do to reduce it? We could divide both of those by 2. So 34 divided by 2 is 17. 100 divided by 2 is 50. So we get 17 over 50. What if we had something like 65%? What's that going to become? So yeah, 65 over 100. What can both of those be reduced by? 5. There we go. Apparently we're still thinking about unicorns. So 13 out of 20. Now it doesn't stay quite that simple. It can be a little more complicated. We can run into like 230. Now let's go 238%. Now, first of all, there are some things in percents that I want to talk about called benchmarks. And benchmarks, we're going to bring them up here and there a couple of different times through the discussion today. One of the benchmarks I want to mention here is 100%. What does 100% represent? What does it mean? The whole thing. There we go. It is the whole thing or the base amount. 100% is equal to 1. One whole thing. So 238% is greater than 100%, much greater than 100%. So when we change this into a fraction, we're going to get something larger than one whole thing, or larger than 1. We still do start out the same way. 238% is 238 over 100. And now we have to reduce this. Well, we'll notice that's an improper fraction. So to me, it's easiest to reduce it just like this. 100 goes into 238 how many times? 2 times, and how much would be left over? 38 hundredths. Now looking at the 38 hundredths, can I reduce that? Yes, both of them can be divided by 2. Perfect. 38 divided by 2 is 19. 100 divided by 2 is 50. Am I done? I need to remember what? The 2. There we go. I can also run into things like this. (56.25%). When I go to change that into a fraction, that's 56.25 over 100. Well, we don't like having decimals within our fractions, so we got to get rid of it. Just like when we were dividing decimals, the way we got rid of those decimal places was we multiplied by 10 or 100 or by 1,000. Here, how many decimal places do I have to get rid of? 2. So I'm going to multiply by 100. Good, to move it to 2 decimal places. So I have the 56.25 times 100 is 5,625. 100 times 100 is 10,000. What can both of those be reduced by? Well, they both end in 5 or 0, which means they can be divided by 5. We'll start there. 5,625 divided by 5 is 1,125. 10,000 divided by 5 is 2,000. What can they both still be divided by? 5 would work again. 1,125 divided by 5 would be 225, I should say. 2,000 divided by 5 would be 400. They can both still be divided by 5, but there's something bigger. 25. Good. 225 divided by 25 is 9. 400 divided by 25 is 16. So that gives us 9/16. We can run into 36 2/3%. That again, if I want to change, now it's already a fractional percent, but I want to change it into just a plain fraction outside of the percent. So 36 2/3% is 36 2/3 out of 100. Now to deal with this, I have 2 options. Option 1 is to use a least common denominator. Well, there's only one denominator in this whole thing, and what's that? Well, there's the 100 is in the denominator, but within the numerator and denominators themselves, there's only one denominator, only one fraction, and that is the 3, right? So my least common denominator would be a 3. So if I were going to do that option, I would take 36 2/3 and 100, and I would multiply both of them by that 3, that least common denominator. Well, 100 times 3 is 300 on the bottom. 36 2/3 times 3. Well, 36 times 3 is 108 plus 2. That's 110 thirds times 3 over 1. The 3's cross cancel, gives me 110 over 1 or 110. So we have 110 over 30. Both of those can be divided by 10 to give me 11/30. That was option 1. Option 2 would be to just flat out divide them. But the key is we have to divide them as fractions. So 36 2/3 over 100 becomes 36 2/3 divided by 100. We have to change them into improper. The 100 is just going to be 100 over 1. 36 2/3, well, we just did this. 36 times 3 is 108. Plus 2 is 110 over 3. Divided by 100 over 1 is going to be multiplied by the reciprocal of 1 over 100. I can cross cancel here, dividing by 10 gives me 10 and 11. 11 times 1 is 11. 3 times 10 is 30. I still get 11/30. Now, if you have the fraction calculator and you're good with it, this option of just dividing might be simpler for you. It'll spit out that fraction for you. Any questions? So I want you to try to convert these in your notes to fractions outside of the percent. 87.5%, 18 1/3%, and 315%. I'll give you a couple minutes to do those three. Take a look. So the first one up here, 87.5% becomes 87.5 over 100. What are we going to do from there? Multiply by only one decimal place, so we only have to multiply by 10. So 875 over 1,000, we can reduce by 75. How about we try 25? I'm not sure if 75 will work. It might, but let's see. 25 is what, 35 over 40. They can still be reduced by 5. Be 7 over 8. 125 would have been reduced by 75 wouldn't have worked. Number 2, 18 1/3%. Where do I start? Well, it's 18 1/3 over 100. Do you guys have a preference whether I use a least common denominator or just divide it out? Okay, I'm going to divide it out. 18 1/3 divided by 100. I'll make it 100 over 1. 18 times 3 is 54, plus 1 is 55. So that's 55 thirds times 1 over 100. Now I'm going to multiply it out and reduce it later so we don't have to deal with cross canceling. 55 times 1 is 55. 3 times 100 is 300. And they can both be reduced by 5. 55 divided by 5 is 11. 300 divided by 5 is 60. 11 60ths. And finally, 315 hundredths. 315% becomes 315 hundredths. I can make that into a mixed number, which would be 3 and 15 hundredths. I can reduce the 15 hundredths by 5 to give me 3/20ths. And I have to remember the whole number of 3 and 3/20. That's where those benchmarks come in, by the way. The biggest mistake I see made is people forget to bring that 3 over. Well, this is 315%. I know this has to be bigger than 1. If I get the answer of just 3/20ths, I know something can't be right there. Next, converting these percents into decimals. You know, we already said 34% is 34 over 100 as a fraction. Well, to convert that into a decimal, we just divide it out. 34 divided by 100. When we divide by 100, what does it do to the number? Just moves the decimal point 2 spots. 34 divided by 100 is 0.34. Since every time we convert one of these percents to a decimal, we're going to be dividing by 100. If I had 87%, that's 87 over 100, or 87 divided by 100. It's just moving the decimal point, 0.87. So to go from a percent to a decimal, we're dividing by 100 or just moving the decimal point. So let's try a couple. 41%, what's that going to become as a decimal? 0.41, good. 287%, what's that going to become as a decimal? 2.87, good. 3% is going to be what as a decimal? 0.03. 5.7% will become what is a decimal? 0.057. Good. 310%. 3.1 or 3.10, either one is acceptable. 0.8%. Good, 0.008. Now here's the one I catch people on all the time. 1/4%. What's that going to become as a decimal? Most people want to say 0.25, but that's still a percent, right? There it is. I heard somebody in Richmond say it as well, 0.0025. This is where those benchmarks come in again. 1% is what is a decimal? 0.01, right? 1/4 of a percent is bigger or smaller than 1%? It's smaller. So as a decimal, it has to be smaller than 0.01. Because a lot of people are tempted to jump in and just say 0.25, but that's still a percent. We haven't divided by the 100 yet. Going the other direction, going from a decimal back into a percent. I might have 0.76 as a decimal. What that means, a decimal number like that, sometimes called a rate, means out of 1. Any number can be turned into a fraction by putting it over 1. So 0.76 really means 0.76 out of every 1. If we want to convert that into a percent is out of how many? Out of 100. So one way we could look at this is equivalent fractions. What do we have to do to a 1 to turn it into 100? Times 100, right? So, but if we multiply the bottom of the fraction, we have to multiply the top by the same thing. 0.76 times 100 is 76. So 0.76 or 0.76 out of 1 is the same as 76 out of 100, which is 76%. Now again, you can see here, every time we convert a decimal into a percent, we're going to be multiplying it by 100. 0.29 is 0.29 over 1. You would multiply by 100 on top and bottom to make 29 out of 100, or 29%. And because we're going to be multiplying by 100 each time, multiplying by 100 just moves the decimal point back to the right 2 spots. So if I have 0.76, what's that going to become as a percent? 76 over 100 or 76%? 0.21 will become what is a percent? 21%. 0.4 will become what is a percent? 40%. 3.7 will become 370%. 0.06 will become 6%. 2 will become 200%. Good. 0.009. 0.9%. Good. The last step is to convert a fraction back into a percent. Now we're going to start off with one that many of you will know. 3/4 is what as a percent? 75%. Good. Most of us knew that. If you didn't know that, how could you have figured it out? Well, there's a couple of ways. One is we could have taken that fraction 3/4. And we can divide it out. 3 divided by 4 is 0.75. And then convert that decimal back into a percent by multiplying by 100 or moving the decimal point. Another way we could have done it is 3/4 can be thought of as 3 out of 4. A percent is always out of 100. To find out how much that would be out of 100. Now, here, this one's pretty simple because what would I multiply 4 by to turn it into 100? 25. So just be 3 times 25 is 75. But what if it was one that wasn't quite that simple? What if it were 5/8? Well, looking at this, what do you multiply 8 by to turn it into 100? Isn't so obvious, is it? To figure that out, we would do 100 divided by 8. That would give us that number there, right? Once we get that number, we're going to multiply the top by that. Make sense? So 100 divided by 8 is 12.5. 5 times 12.5 is 62.5. So that's 62.5 out of 100, or 62.5%. Now there's a shortcut here, and it comes from what I did right in here. You'll see I took the 100 divided by 8, and then I multiplied the 5 by it. Well, it requires us to fudge our order of operations a little bit, but we can just do this. 5 times 100 and then divide by 8. They refer to it as cross multiply and divide. We did this with our ratios and proportions before. So you take the two numbers that are diagonal to each other, in this case it's the 5 and the 100, you multiply them, and you divide by the one that's on the other diagonal with the missing number. So if I have 3/7, and I want to turn that into a percent, it's 3/7 equals blank out of 100. 3 times 100 is 300. Divided by 7 is going to be 42.8571429 approximately, right? Now, obviously, I don't want to leave it out there. As a general rule, unless you're told otherwise, my math lab will often tell you to round to a 1/10 of a percent or a 100th of a percent. If you're not told, assume you can round to 100th of a percent. So this would be 42.86%. That 100th of a percent comes from banking industry standard is usually 2 decimal places on your percents. So we can convert from percent to decimal or percent to fraction, and from the decimals and fractions back into a percent. So it's time to start working with the percents a little bit. I want to come back to that idea again of benchmarks. You know, we've talked about some standard benchmarks of 100%, which is just 1, the whole thing. But there are some other pretty simple benchmarks out there, one of which is 10%. 10% is 10 out of 100, which of course reduces to 1/10. To find 1/10 of something is relatively simple. For example, if I have the number, let's just say 4,500. What is 10% or 1/10 of that? Well, I would just move the decimal point over 1 spot, wouldn't I? 450 is 10%. You either drop a 0 or move the decimal point over, however you want to think about it. 1% is another pretty simple benchmark. 1% is 1 out of 100, or 1/100th. To divide something by 100, we move the decimal point over 2 spots. That would just be 45 is 1% of the 4,500. Does that make sense? Now, there are other benchmarks we could talk about, and it all depends on how easily mental math comes to you and how simple the number is to work with. For 4,500, 50% might not be that easy, dividing it by 2. If we had something like, 6,400, 50% wouldn't be so bad. 50% is 50 out of 100, or 1/2. Yeah. Okay, so that's 50 out of 100, or 1/2. 6,400 is easy to find half. What's half of 6,400? 3,200. Okay. If you can find 50%, well, then 5% isn't so bad. 5% can be thought of in 2 ways. We could think of it as 1/10 of the 50%. So I'd be just taking this number and moving the decimal 1 spot, 320. Or it can be thought of as 1/2 of the 10%. 10% of 6,400 would be 640, and half of that is 320. Like I said, which benchmarks you use depends on how comfortable you are with mental math, and it might depend on what number we had. Doing the 50% of 4,500 isn't as easy because 45 doesn't divide by 2 real simply. It's not terribly difficult, but it's not right there for you. Some of the patterns here, like finding the 5%. Some of you might prefer to do half and then move the decimal point. Some of you prefer to do the decimal point and then take half of it. I've mentioned several times before that math is about patterns. That's how I can do some of the calculations I do very quickly, because I see the patterns. And once I start to do the calculation, I see the pattern, I can continue with the pattern. The problem is everybody sees different patterns. Like I showed you here, there's 2 different ways of doing it. To some of you, one of those might make a lot more sense than the other. Some of you, neither one of them might make sense. There might be a different pattern that works better for you. But that's the key, is finding those little shortcuts that help you do the estimation. So anyway, these benchmarks can actually help us do some rather complex calculations. For example, if I ask you to find, let's do 13% of 2,800. Well, 13% here, I'm going to break it down as 10%, 1%, 1%, and 1%. That adds up to 13%. 10% of 2,800 is 280. 1% is 28. If I add those all up, anyway, 364, that is 13% of 280. Notice I didn't do any fancy calculations. I'm just simple, quick estimates using those benchmarks. I might ask you to find 19% of 400 or 4,200. Well, 19%, I might find that as being 10% plus 10% minus 1%. 20% minus 1. 10% is 420. Another 10% is 420, which adds up to 840. And I am subtracting 1%, which is 42. So 798 is 19%. Yeah, we're going to get to that. Yep. I'm just showing you some little estimations here before we get to the full out calculation. But yes, you're absolutely correct. So you can see here, there are little strategies. Well, like I said, some people might prefer to do 10% plus 5% plus 4 ones. There's different patterns. But this type of thought process, when I'm doing multiplications, is going through my head. If I multiply, even if I'm multiplying by 19 and other numbers, I'm using that same type of thought process. So just something to keep in mind. Okay, so now let's actually get to the actual calculations. So outside of the benchmarks, there are a couple of methods that are used for calculating with percents. And I'm going to start out by presenting the one that I've found through the years that tends to make the fewest mistakes if students use it, and that is the proportion method. And that proportion method involves what we were doing when we were converting those fractions. You know, the percent is always out of 100. And that equals some other piece over here. So let's look at some examples and we'll make that proportion method work. For example, let's ask you to find 35% of 80. So I'm going to start with the percent. I tend to always start with the percent in these problems. 35% is 35 over 100. Before we go any further, let's define what this 35 over 100 really stands for. The 100, as we mentioned before, think of it as 100%, is the whole thing. Or sometimes the starting amount. It is the basis of our calculation. The top, then, the 35, is a portion of that, a piece of that we're focusing in on. I'm going to call it a portion of interest. It's a piece of that whole thing that we are focusing on. So on the other side of this proportion is another ratio, another set of two numbers. One of those numbers represents that piece, that portion of interest. The other one represents the whole thing. Well, for this to be a problem, one of those numbers has to be missing. And it is. We only have the 80 here. So is the 80 the piece of interest or is it the whole thing? It's the whole thing, yes. And one of the cues here is the word of. We can think of that as out of 80. Implies that 80 has to go on bottom. It's the whole thing. Now, some of you were probably taught a little mnemonic. Is over of. And that does work in these basic problems like this. When we get into word problems after our break, those can cause some problems because the verbiage gets a little more complex in the word problems. And so that might not quite hold true for those. So now to find the missing number here, we use that cross multiply and divide. 35 times 80 is 280, or 2,800. Sorry, and then we divide by the 100, which is 28. So 28 is the 35% of 80. Any questions there? A slightly different wording. Blank is 140% of 35. Now here we're going to start with a percent. 140% is 140 out of 100. Now, since that percent is bigger than 100, what can we say about our other numbers? That portion that we're focusing on is going to be bigger than the whole thing, isn't it? So on the other side, we've got the 35. Does that go on top or bottom? Bottom. Again, of 35, think of that as out of 35, implies it goes on bottom. Also, blank is 140%, implies that missing number matches up with 140. So we will cross multiply and divide. 140 times 35 is 4,900. Divided by the 100 is 49. 49 is 140% of 35. A little bit different still. Oops. Let's do this. 20% of 90 is blank. I still have the percent, so I'm going to start with 20%, which is 20 out of 100. On the other side, does the 90 go on top or bottom? Bottom. Again, it's of 90. Think of out of 90 is on bottom. 20% is blank. That blank number goes with the 20. So we'll cross multiply and divide. 20 times 90 is 1,800. Divided by the 100 is 18. So 20% of 90 is 18. So this one here is slightly different. 42 is 60% of blank. Well, I have the 60%, so I'm going to start out with 60 over 100. The 42 go on top or bottom? Top. 42 is 60%. Implies that 42 matches up with the 60. Now we'll still notice the missing number's in a different spot now. It had been on top here in all of our problems. Now it's on bottom, but we're still going to cross multiply and divide. Our cross multiplication is a different direction now. It's 100 times 42 is 4,200, and then we divide by the 60, which is going to be 70. 42 is 60% of 70. If I say 40, so my percent symbol disappeared on me. 40% of blank is 36. Well, again, I start with my percent. 40% is 40 out of 100. Where does the 36 go? On the top. Of blank, implies out of blank, implies that missing number's on bottom. When I cross multiply, what two numbers am I going to multiply? 136 is 3,600. And divide by the 40 gives me 90. 40% of 90 is 36. Here, 48 is blank percent of 60. Now, I've been telling you that we always start with the percent. Unfortunately, the percent here is missing. We will still start with the percent, however. Blank percent is just blank over 100. Now, on the other side, we're going to match things up. 48 is blank percent, implies the 48 matches up with that missing percent. Of 60, read that as out of 60, implies that 60 is on bottom. Notice again that the missing number's in the different spot again, but it's still solved by cross multiplying and dividing. What two numbers are we going to multiply? 100 times 48 are diagonal, so that's 4,800. And then we divide by the 60, which will give us 80. So 48 is 80% of 60. We might have blank percent of 120 is 18. Again, we don't have the percent, but we're going to start with it. It's just going to be blank over 100 equals, on the other side, where does the 120 go? Top or bottom? Bottom. Of 120 implies out of 120. It's on the bottom. 18 then better go on top. We'll cross multiply 100 times 18, 1800, divide by the 120, which will be 15. 15% of 120 is 18. You'll notice in all of these calculations, it ended up being the same process. Even though we might have been missing different pieces, it was always, once we got them in this proportion, cross multiply and divide. There is another method that many of you might be familiar with. And this method is called the rate method of proportions. And the rate method uses just that, a rate. And what a rate is just the decimal form of a percent. So 70% is 0.7. So if I'm looking at the first one here, I would start out by taking 35%, and I would make it 0.35. Then I would take that 0.35 and I would use it to multiply the 80. 80 times 0.35 is 28. Now that seems a little bit easier than the proportion, a little quicker. And for this type of problem, it is. This next one's a little bit different, but it's the same type of problem. 140% becomes what as a decimal? What is that as a rate? 1.4. So I'm going to take that 1.4 and use it to multiply the 35, which is 49. Again, pretty quick and simple. Here, 20% is 0.2. I take the 90 times that 0.2, gives me 18. Again, same answer. I'm not trying to sell you on the rate method, however. I'm actually trying to do just the opposite. As I'd mentioned before, the proportion method tends to have students make fewer mistakes. And let me show you why. Because this problem is different. This is dealing with 60%. What is 60% as a decimal? 0.6. Well, in this problem, we have the 42. But it's not going to be 42 times 0.6. It would be 42 divided by 0.6, which would give us the 70. Similar to our next one down here, 40% is 0.4. But it's not going to be 36 times 0.4. It would be 36 divided by 0.4. Gives us the 90. So if you want to use the rate method, you have to know, do I multiply by the rate or do I divide by the rate? In fact, in like ones like this one where we're not given the percent, you have to take that portion of interest divided by the whole thing, the 60. You would get 0.8, then you'd move the decimal. That is a rate, So we move a decimal to make it 80%. I'm not trying to discredit the rate method completely. There are applications where the rate method is very useful. If we are going to be consistently looking for the portion of interest, like we were up here, we turned our percent to a decimal, multiplied by it. There's a lot of applications in business where we're going to be doing that over and over again. And if that's the case, the rate method is much simpler. But for general problem solving, this proportion method usually provides a lot fewer mistakes. I got a few minutes long-winded there. It is 4 minutes after the start of our break. So let's take our break. It's 4:24. Let's come back at 4:34. So we've done the basic calculations here. Now it's time to take a look at everybody's favorite word problems. This is one of the reasons why I like that proportion method, because in a proportion, things have to match up. We're going to have our percent over 100 here. And the other proportion, whatever goes here has to represent the same thing that's represented by the percent. Whatever goes here has to represent whatever the 100%, the whole amount, or the beginning value, which is always the 100%. So those things have to match up. That's why the proportion works really well for these word problems. So let's look at an example here. PFM Corporation estimates weekly profit as 12% of gross sales. Find the gross sales for a week where profit is estimated at $38,400. Well, just like with our other problems, I am always going to start out with the percent. So here the percent is the 12%. So 12 over 100. Before I start filling in the other side of this proportion, I'm going to label what does the 12% represent? Well, the 12 is the weekly profit is estimated at 12%. What does the 100% represent? Well, 12% of what is the weekly profit? 12% of gross sales. The whole thing is gross sales. Now, if you think about this for a second, it makes sense. Whatever is represented, the 100% is the bigger pot of money, the bigger pile. And the 12% is a smaller pile that's part of that big pile. The gross sales is everything you sell. The profit is a little piece of what you sold. You have other expenses that come out of there. So that makes sense. So on the other side over here, we're going to put the $38,400. Does that represent the weekly profit or the gross sales? The estimated weekly profit. So that goes on top. So now we find our gross sales, find the gross sales by cross multiplying 100 times 38,400 divided by 12 is what, 320,000? Does that look right? So that is our gross sales. So setting it up in that proportion and then making sure everything matches up helps us keep track of where things should go. Let's say that Sam was earning $14.50 per hour. Sam receives a 58-cent per hour raise. What percent raise did Sam receive? Well, we're going to start with the percent, but we're missing the percent. What percent means we are finding the percent here. Now we have to ask ourselves, if we knew that percent, what is it representing? Well, it's what percent raise. What percent is that raise? So the percent is representing the raise. The 100, we said always represents either the whole thing or the starting amount. In this case, since it's a change, that represents the starting amount. What would the starting amount be here? The 1450. You are absolutely correct. So on the other side over here, the 1450 goes on bottom because that's the starting amount. It has to go with the 100. So that means what goes on top? The 58-cent raise. So then we'll solve this by cross multiplying and dividing. 100 times 0.58 is 58. Divided by 1450 is 4. So that's 4 out of 100, or 4%. Another thing that these proportions are good for helping out with is avoiding calculating something we don't need. For example, let's say that Pat pays, let's say 32% in taxes. How much does Pat take home? In other words, how much does Pat get to keep in a week where Pat earns $650? Do we have a percent here? 32%. So 32 over 100. What does the 32 represent? It'll represent the taxes, yes. Now the 100 is a little trickier. The 100 is going to be the gross pay, or in other words, the amount that Pat earned. On the other side, do we have any other numbers that describe either the taxes or the amount that Pat earned? The 650 describes what Pat earned. Are we looking for the amount of taxes? No, we're not. But if I know the amount of taxes, will it help me find what I'm looking for? Well, it can, right? Let's do this. Let's find the amount of taxes. Should be 650, thank you. Yes, that should have been 650. Sorry about that. So let's cross multiply and find this number. 32 times 650 is what? $20,800 divided by the 100, 208. That's the amount that Pat pays in taxes. What do we want to find out? How much Pat takes home. Well, Pat takes home $650 minus 208, $442. So by labeling our ratio and keeping track of that proportion, it allowed us, once we did the calculation, to realize that we do have to take an extra step to actually get to the answer to that question. This brings us to something. Oftentimes, there are multiple percents in a problem. There's something called complements. You don't necessarily need to know the word, but you need to understand what it means. The whole thing, the whole amount is 100%. That whole amount is going to get divided into two parts, a portion of interest and the rest, or everything else. Well, if our portion of interest is, let's say, 30%, what percent is the rest of it? 70. How'd you get that? Yeah, just do 100 minus 30 equals 70%. Those 2% have to add up. Since they combine to make the whole thing, they have to add up to 100%. And this happens a lot when we're dealing with percents. We don't want the number that is represented by the percent. We want the number that's the rest of it. It's the complement of the percent. For example, let's say that Sam buys let's say a table. Priced at, excuse me, $800. But it is marked 40% off. How much does Sam pay? So here we have the whole thing, the whole amount. The piece that we're given here, the 40%, represents what? That's how much it's marked off, right? That'd be a discount of some sort. The rest of it would be what percent? 60. 100 minus 40 would be 60%. That's the amount that Sam paid. Are we concerned with the discount or the amount that Sam paid? The amount Sam paid. So what we really want is the 60%, not the 40%. So we'll find 60% of the $800. We can cross multiply. 60 times 800 divided by 100, which is going to give us $480 that Sam paid. Does that mean that we can't use the 40%? Well, not necessarily. We could have used 40%. If we cross multiplied and divided, we would get 320 here. But 320 is not our answer. We would have to take that extra step and take the full price and subtract the 320 is the discount to get the 480 paid. So by using that complementary percent, the complement, it's just a little bit quicker. Also, there are times where we have to use that complement. For example, after a 20% discount, Stacy pays $496 for a chair. What was the full price? Well, here, if I did the 20%, that 20% would be 20 over 100. The 20 represents the discount, and the 100 represents the full price. Do we know the discount? No, we don't. It's 20%, but we don't know the dollar amount. Do we know the dollar amount of the full price? No. The 496 is the amount paid after the discount. So it doesn't represent either one of these values. So we can't do anything with the 20%. The complement of the 20%, if it's a 20% discount, what the percent paid would be 80%. 100 minus 20 equals 80. That 80% represents the amount paid. 100 is still full price. So now this allows us to put in the $496 is the amount paid. That goes with the 80%. And now we can find the full price. 100 times 496 divided by 80 is what, 620 bucks? We can also have percent increase. If there's an increase by a percent, this happens actually quite often. If you do any travel, there's all sorts of travel fees and taxes that go on. If you ever looked up a hotel room and it says it's 40 bucks a night, you get there and they charge you 52. It's because there's all sorts of fees for hotel rooms and stuff like that that go on there. Those are considered percent increases. So for example, let's say that Peyton purchases a ticket for $80, but there is a 25% tax on top of that, on top of the ticket price. How much does Peyton pay? So we have that 25%. Of course, it's 25 out of 100. The 25 is the tax. What's the 100% represent here? What is the full thing, their initial price? $80, yes. That is the ticket alone. So on the other side, that $80 goes on bottom. We can cross multiply and divide here. 25 times 80 divided by 100 is going to give us $20. That $20 though represents the tax. Is that what we're looking for? Sort of, but not quite. We're looking for how much does Peyton pay total. How would we find that? Perfect. Take the $80 ticket plus the $20 tax. You get $100 total. Well, similar to the complement, when we have a percent increase, there's a shortcut we can take. We can do 100%. Instead of subtracting the percent, we would add it. 100% plus 25% is 125%. So what is paid after the tax is 125% of the ticket price. So you can use 125% instead of 25. Now when you cross multiply and divide, 125 times 80 is 10,000. Divided by 100 is 100. So that $100, you get that all at once. Now looking at this may seem not terribly different in the amount of work compared to what we did up here. There are going to be problems where we have to use this idea. For example, after an 8% increase, a plane ticket costs $450. Find the original price. I'm going to give you guys about a minute to work on this. See if you can come up with it on your own. How many of you got $414 as your answer? Okay. That is the predictable answer. Unfortunately, it's not correct. Because you found 8% of the 450 and you subtracted it. The problem is the 450 is not the starting amount. That 8% is based off the starting amount. So we had 100%. We added the 8% to it, gave us 108%. So what's being represented here is 108% is the price after the increase, which is the 450. This is that starting amount, the base amount. So 100 times 450 divided by 108 is $416.67. Yeah, 414 would be if you found 8% and tried to subtract it. The problem is you can't do that because the 8% doesn't come off the 450. Okay, we will talk more about percents on Thursday and do some applications of percents and stuff like that. Hopefully we'll have a little bit of time to review for our test on next Tuesday. There is a new quiz that is due tomorrow. That's Wednesday at 11:59 p.m. And there is a new homework that is due for Thursday.